Okay, so let's take a look at today's lesson. We're going to be looking at the definition of trig functions. Many of you, this should be a review. This should be something that you're familiar with already. Perhaps not all of it, but quite a bit. So these right here, sine, cosine, and tangent, we would have learned that in geometry, right? The sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. These are things that we should be familiar with, and that should be okay, right? The SOHCAHTOA thing is how I keep it in order. So tangent, we've been actually using tangent as being sine over cosine already, so that should be comfortable and familiar, so that shouldn't be an issue. Let's look at the reciprocal functions. So the reciprocal of sine is cosecant. Notice how sine is opposite over hypotenuse, but cosecant is hypotenuse over opposite. That's what it means to be reciprocal, and that is the x and the y's have switched places. Or, excuse me, the fraction has flipped upside down. The x and the y hasn't switched place. The fraction is just flipped upside down. Instead of opposite over hypotenuse, we're hypotenuse over opposite. That's it. We just flip it upside down. So cosine's reciprocal is secant. And why they don't match the letters to the letters, I don't know. Wouldn't that be nice if like sine went with secant and cosine went with cosecant? Then you could remember like the s's go together, c's together. Well, no, of course, it's not going to be like that. So just remember it's the opposite, right? So cosine's reciprocal function is secant, and then tangent's reciprocal function is cotangent. Again, notice the fractions are switched. They're reciprocals. They're switched upside down. Another way to write the reciprocal of cosine, basically, here's our sine. The reciprocal cosecant can also be written as 1 over sine. That's the same thing. 1 over sine is the same thing as cosecant. And 1 over cosine is the same thing as secant. And then 1 over tangent is the same thing as cotangent. So there's several ways that you can write these things. Okay, and notice here on cotangent, it also is, cosine over sine is cotangent. These are all equivalent expressions. Okay, so last week we actually already talked about sine squared and what that means. This is just a reminder. If the 2 right here, notice how the 2 is on the trig function. Right here, it's attached. Okay, it's not on the argument. So that means that is sine theta quantity squared, which means sine times sine. Those are just equivalent expressions. We want to make sure we understand that. So it's not the argument that's squared. If the argument was squared, it would look like this. Okay, that's what the argument squared would look like this. This is the function being squared. Okay. So let's go to our next slide. We have a couple of different examples of using these trig functions. One thing I want to point out is the word exact. Another issue about reading directions, right? Exact. When you see that word, that should tell you something. Exact means like 6 pi, not like 6 times 3.14 blah blah blah, right? It means exact. It doesn't mean an approximation or rounding. So when you see this word exact value, that should give you an indication that these are special angles, right? Special angles are really the only ones we could get exact values for without using our calculator. So our exact is special angles. So I am big about drawing. I'm going to draw the coordinate plane. I really need to know, I need to see where negative pi over 2 is. So this is 0. We would do backwards rotation, and our negative pi over 2 would be right here, right? And then I would write down the coordinate point just to kind of help myself. So x is 0, y is negative 1. Now it wants us to find the exact value of the 6 trig functions. So what I do is I go ahead and just write them out. So I have sine of negative pi over 2, and I would write sine and cosine and tangent underneath each other, and I'll show you why in just a second. It makes my work easier. You certainly can write them in any order you want, but this is what I do, and so I write tangent negative pi over 2. I put their reciprocals right across from them because we're just going to be flipping the fraction upside down, right? It would be easy for us if we just write them right across from each other. So across from sine, I would write cosecant. Across from cosine, I would write secant. And across from tangent, I would write cotangent, just, to make my work a little easier. So we know that sine is the y value, right? The y value, so sine, here's the y value, so that's a -1. So if I flip -1 upside down, I'm still going to get -1. So sine and cosecant happen to have the same value there. Cosine. Cosine we know is the x value, so cosine is 0. Now if I flip 0 upside down, I'm going to have some problems, right? If I flip it upside down, I'm going to have 0 on the bottom. We know that that's bad, right? That's not good. So that would be undefined. That makes secant undefined at -π/2. Then tangent we know is sine over cosine, or y over x. Y over x, which is undefined, right? 0's on the bottom, so that's really undefined. And for undefined, you can just put UND period. That's fine for undefined. Now, if I flip that upside down, I have 0 over -1. Now, 0 over -1 is 0. That one's okay, right? 0 in the numerator over a number is 0. So that one works out fine. And that's our first example for finding the exact value of the six trig functions. We okay with that one? Okay, so let's look at the second one. So we have 675 degrees. We can see that there is an extra rotation on here that we need to pull off so we can see which quadrant we're in. So I'm going to pull off the 360, so which would be one full rotation. And when I do that, we get 315 degrees. All right, so let's see what that looks like. That puts us in the fourth quadrant. This location, 315, that means this is 45 degrees, right? So this location, my x value is going to be √2/2, and my y value is -√2/2 at that location, at 315. All right, so sine, I'm going to go ahead and write out all, I have sine of 675, cosine of 675, tangent of 675. Then I'm going to write their reciprocals right across from them just to make my life easier. So we have cosecant of 675, secant of 675, and cotangent of 675. Okay. So let's look at our diagram. So sine we know is y, and so our y value is -√2/2. Cosecant, we're just going to flip that upside down and get -2/√2. Now let's talk about rationalizing. I encourage you to leave it alone. Don't rationalize. I encourage you to not rationalize. You need to know how to rationalize because many times multiple choice answers are rationalized. But to have to do it every time, it's not necessary. As long as you know. So if this was my answer and this was a multiple choice problem and you notice that it didn't look like that, you would know what to do, right? You would know to rationalize it. That's all we're working on, is to know how to do it. I don't want you to have to do it every time. It takes time and it's not necessary. So just leave it just like that. Okay? So cosine of 675 is our x value, or √2/2. Secant of 675, we're going to flip that upside down and get 2/√2. Okay. Tangent is opposite over adjacent. So really, you can think about it, or you can think about it as y over x, right? Tangent is y over x. -√2/2 over √2/2. I think we all recognize that that simplifies to a -1. Right? So tangent is going to be -1. And then if I flip -1 upside down, I still get -1. All right, so those are our two examples with exact values. In other words, these are special triangles, special values. Are we okay with that? Now, we are going to be asked to find like for example here, these are not unit circle values. Find six trig functions of theta. Notice they don't even tell us what the angle measure is. They just say theta. Okay? Now let's think about this over here. What did the angle measure do for us? Well, what it did is it told us where to go, right? It told us which quadrant to be in, and it told us which values we would be using. Other than that, we really didn't need it, did we? We just needed to know where it was and what values to use. On these problems, they're actually telling us where it is and what values to use, so we really don't need to know what theta is. In fact, to determine what theta is, we would actually have to use a calculator. Okay, and it's not necessary. We don't need it. So we just need to follow whatever information they gave us, and it's really important for us to draw the graph. Now, I have students that like to conserve energy. They don't want to write anything down that they can get away with not writing down. And I will tell you that writing this down is going to be a huge help. Half of the time when people don't write it down, they get it wrong, because these are very sign specific. Like if it's in the third quadrant, I need to know that x is negative, right? I need to know those things. So it's really important for you to draw these diagrams. And there are times where I give points for the diagram. So we just need to get used to, drawing the diagram. So part A, it tells us the terminal side passes through negative 5, 2. All right, so what we do is we go to negative 5, 2 and put a point. Okay, and so that our triangle is going to come from the origin to that point, and that's our triangle. So we use this information to find the side measures. So here we know that's a negative 5, and then this is 2 up. Now, I always like to tell you where the most common mistakes are that students make. One of the most common mistakes is dropping the sign. Like just not putting, just saying that that's 5. It's going to cause like more than half your answers to be wrong. So we need to be very careful about our signs. Very careful about our signs. So now we're going to calculate. We need the hypotenuse, right? We're going to need that for calculations. So we use Pythagorean Theorem to calculate, negative 5 squared plus 2 squared is c squared. So we know that that gives us root 29. Now, just a side note, the hypotenuses are always positive. It doesn't matter what quadrant you're in. So you don't need to worry about the hypotenuse's sign. It's always going to be positive. The signs you need to be concerned with are the legs of the triangle. Make sure you have the right sign there. All right, so let's, we want to find the 6 trig function values. So let's do that. So we do sine of theta. I want to talk about this for just a moment. I can't tell you how many students write sine equals. Okay, this has no meaning. Okay, this is a partial. That's partial. I mean, the argument's missing. The poor little thing, its argument is with it all the time. It's not a multiplying, it's part of it. That angle measure has to stay with the sine. Okay, we don't just write it like this. Okay, we don't do that. That's a no. Right? We need to write it with its angle measure. We don't know what it is. It's not really important at this point, but we need to write that it's an angle measure. So we have sine, we have cosine, and we have tangent. Then over here we're going to have cosecant and secant and cotangent. Okay, so we're going to look at our triangle and we're going to read all the values off of our triangle. So sine we know is opposite over hypotenuse. So that's going to be 2 over root 29. And so cosecant is going to be the reciprocal of that. We just flip that upside down and get root 29 over 2. Okay? Are we okay? Am I going too fast? Okay. So cosine is going to be adjacent. Adjacent, which would be negative 5 over hypotenuse. And secant would be the reciprocal. We would flip that right upside down. So it would be negative root 29 over 5. Tangent we know is opposite over adjacent. So opposite would be 2, adjacent would be 5. And cotangent, we're just going to flip that upside down. It would be negative 5 halves. And those are my 6 values. See, we didn't even need to know what the theta was, right, to be able to do that. We just do it from what the triangle says. Okay? Our last one, again, these are going to give us all kinds of clues to tell us where the triangle is. In this one, it tells us it's in quadrant 3. All right, so let's just go ahead and draw a triangle in quadrant 3. And the theta, and I'll just be sure to mark my diagrams, the theta is the angle next to the origin. It's always the angle next to the origin. All right, so this tells us we're in quadrant 3, and it tells us sine is negative 2 over 3. Okay, so sine is opposite over hypotenuse. Now, I need to point something out here about the sign of the negative 2. Some students get really confused and think that whatever is in the numerator is what the thing that's negative. That's not always the case. Okay, we need to look at the context. we look at what quadrant we're in quadrant 3. So would the y value be negative, or would the hypotenuse be negative? Well, in this case, it's the y value that's negative, right? It's not the hypotenuse. So it just so happened that it is -2. I just want us to recognize that the normal way to write fractions, negative fractions, would be to put the negative in the numerator regardless of which one of these is negative. I hope we're clear on that. Sometimes students get confused about that. Okay, so we're just looking at, we know that the y value is what's negative. All right, so now we're missing a side measure, so we're going to have to do Pythagorean theorem to find it out. So we have -2 squared plus b squared equals 3 squared. So what is that, √5? Okay, we write √5 down, and then we stop back and think, is there a sign? Is it negative or positive? I want you to always think, is it negative or positive? Don't just randomly write numbers down. Okay, we're in, let's see, x is negative over there, right? X is negative, so that should be -√5. Okay, so now we have all the numbers that we need in order to complete what they asked us, which is the 6 values. So we have sine theta, cosine theta, tangent theta, and then we have cosecant theta, secant theta, and cotangent theta. All right, so let's read the information off of our triangle. So sine, actually they already gave it to us, right? It's right here. I mean, we should be able to read off the triangle as well, right? Opposite over hypotenuse. So sine is -2/3. And that means cosecant is that reciprocal, so we flip it upside down, -3/2. Cosine is adjacent. Adjacent would be -√5 over hypotenuse. And then secant, we're going to flip that upside down, and we get -3 over √5. Okay, is everybody okay? Okay, then tangent is opposite. So opposite over adjacent, which would be a -2 over -5, right? Which would give me 2 over √5, right? Because the negatives cancel out. And then cotangent, we would flip that upside down, and we would get √5 over 2. And that is the basis of the lesson today. Are we doing okay? Okay.